For example, they have collected this rain information and they have analyzed it properly. They would have found out that this year there may not be a rain. They did not find it out, hence they were in trouble. And this is just one example. There are so many other examples. There are so many, like for example, there in Louisiana in USA, there were hurricanes in the past, but people just failed to realize the hurricanes will be coming every 10 years. So they didn't take a proper note. So, just an example, right? So it's not true. So basically, what they should have done is analyze the data, identify the outcomes from the existing data. The information was already there, we just didn't see that coming. So to do that, using the normal databases, it's very, very, very difficult if it is not impossible. As I said earlier, the scientists will understand the outcomes based on certain n number of variations. So for that you need to build certain models. When I said models, I'm not talking about data models, I'm talking about quantitative models, qualitative models, etc. These quantitative and qualitative models are the algorithms likes of Monte Carlo simulations. And to these algorithms, the data, various variables will be given as inputs. And based on those inputs and based on the data that you hold about the, let's say, for example, rain data, snow data, sun data, temperatures data, and train accidents data, whatever it might be, right? If you start playing with the data, you will understand there might be some relations between some unrelated events on the cells, right? So basically, you need to be a explorer. In other words, you need to be a scientist to understand the outcomes of the data. That exploration of the data over a period of data, over it collected data over a period of time, it could be 20 years, 30 years, 40 years, or whatever, 100 years, or whatever. So that's volume. And data comes in different formats, different shapes, all sizes and shapes and all these things, right? So it's velocity, it's faster, and then coming in with different kinds of varieties. It could be a picture, it could be a diagram drawn by some mad scientist, and it could be a normal data, whatever, and variance. You know, for example, Prime Minister, Indian Prime Minister Modi ji came to UK, and there was a huge uproar in the social circles on various topics, and then it lulled down. So certain events will actually trigger certain events. So that data, all these things analyze and then define, saying that okay, this year there may not be any rain, so let's not get this stock of raincoats anymore. There are organizations who do this very seriously, likes of supermarkets, likes of Walmart. Okay, sometimes you go in a season to find out swimming wear, and you will not find it out because in summer they predicted that it could be cold and nobody goes to beach. And that year, this happened many times, and that year actually the weather was cold and people were not going to beaches, hence there is a low demand of swimming wear. There are so many examples for that. So how do we do that? Just you have high data, you have a big data environment, and you have a computer, you have a laptop. How do you do that? Generally, most of the times, since till recent past, till recent 4 years ago, people used to extract the data sets by sets and minute sets, about whatever Excel spreadsheet allows you to do. People used to extract the data into Excel spreadsheets, run some macros, and do some analysis, and it used to be fairly kind of accurate. I know a friend of mine, he's a British. I used to basically note down all the performances in the league tables of the local cricket matches, and now he has made um, a list of probables for England team in one of the years, and he told me that he created this on an Amstrad computer. If those people who have no knowledge what is meant by an Amstrad computer, is nothing but a old timed personal computer which used to have 1.44 stroke 1.2 megabytes of floppies as input output devices, and probably about 20 megabytes of hard disk space, and having about 2 megabytes of RAM. Yes, those machines existed. So I have seen those machines. I have worked on those machines. All right, and if I have installed Oracle using 64 floppy disks once upon a time. So yeah, these things used to happen. Nowadays, it's not anymore. So using those computers, he could create a model which will predict the England English cricket team based on the huge amount of data that he has collected on his Amstrad computer. Just imagine, just assume the kind of analysis that you can do with whatever data available today, right? So, what I'm going to do is I'm going to introduce a couple of things. One is ClickView is a company who has a number of products. They it is used, it is easy to build some reports, build some analytics, do some research on the data. Also, we take SAS. SAS started as a statistics company, but however, they started uh, uh, releasing a number of products, especially called Enterprise Guide and Enterprise Data Miner. So, I am going to start a training course which will teach you from the top level. We will take, let us say, a government organization. Let us say a spend is about in on specific public services. The spend is about £100 billion, and out of it, what will happen if the error and the fraud is about 8%? That's a tune of £8 billion, right? £8 billion, a country like India can erase their budget deficit, right? So, such kind of things happen. I have seen such kind of things in various customers. So, in my next video, I'm going to discuss these things. I'm going to discuss what we can actually find out using this enterprise guide and enterprise miner, and how it can use. And of course, in my training course, which I will publicize shortly, will cover detailed steps to take and how to utilize the big data as the source for this enterprise guide, SAS Enterprise Guide and SAS Enterprise Data Miner. Thank you very much for listening to me patiently. I know this video is double the size of the previous two videos, so hope you enjoy. Thank you very much. Bye bye.